So in this question here, just from the picture, we see changes in height. And so if we have delta z's, we should be thinking that there's something to do with gravitational potential energy. That's just something we should see. So we've got a car running out of fuel at the top of hill A. The guy hopes to coast and make it to the service station with the engine off. There's a small hill B. The distance from hill A to B is 0.2 kilometers. So we know this is 0.2 kilometers. And it's a key for us to note that the units are in kilometers, not meters. And from the hill to the service station is 0.4 kilometers. So 0.2 kilometers is 200 meters. 0.4 kilometers is 400 meters. So we know this height is 50 meters. This is 30 meters. And when the car reaches hill B, the speed, V, is 5 meters per second. Starts from rest at hill A, so V0 equals 0. Show that the average frictional force is 750 newtons. So where they're telling us that's the answer, they're not asking us to plug that in, but we should do some things and come up with the same answer. We know the mass is 800 kilograms. Well, the way I recommend approaching this is to be systematic about all of these things. So at hill A, there is information. At hill B, there is information. There's what happens in transition to the service station, and there's at the service station. So at hill A, there is gravitational potential energy. So EP equals mgh, mg delta z, excuse me. The mass is 8 times 10 to the second. Gravitational acceleration caused by gravity is 10 to the 1. And the height is 50 meters, so that's 5 times 10 to the 1. So when we multiply those out, we get 40 times 10 to the 4th joules. Notice that becomes very easy when we do it this way. And when we look at the kinetic energy, 1/2 mv squared, the velocity is 0, so the kinetic energy is 0. So we have a total mechanical energy of 40 times 10 to the 4th joules. Now, at location B, we have gravitational potential energy as well. So we have our same 8 times 10 to the second. Gravity is 10 to the 1, and delta Z now is 3 times 10 to the 1. So that is 24 times 10 to the 4th joules. So we can see we've lost potential energy, but we also have kinetic energy. So kinetic energy is 1/2 8 times 10 to the second times the velocity 5 squared. So that's 2.5 times 10 to the 1. So 1/2 of 8 is 4 times 2.5 is 10. So we've got 10 to the 1 times 10 to the 1 is 10 to the 2, 10 to the 4. So we have 1 times 10 to the 4th joules. So that gives us a total energy now, total mechanical energy of 25 times 10 to the 4th joules. So we can see that there are 15 times 10 to the 4th joules missing. By being systematic, we're able to see that that is missing all around. So what's happening then is, as the car goes from A to B, there is friction acting on the car, which causes it to lose kinetic energy. And so therefore there's energy lost to the system. So let's see what that force would be. So we have the work done is equal to the average force times the distance. And so that average force then would be the work divided by the distance. Now the work lost is, or the energy lost, is 15 times 10 to the 4th. And the distance is 200 meters. So that's 2 times 10 to the second. Well, that gives us 10 to the 2 on top. 15 over 2 is 7.5 times 10 to the second newtons, which is 750 newtons. So we have indeed shown that the average frictional force was 750 newtons.